Space is vast, it's filled with mysteries. One of the biggest, fast radio bursts, or FRBs. These are intense pulses of radio waves that flash for just milliseconds and then they vanish. Scientists are baffled. Where do these bursts come from? What causes them? The answers could change how we see the universe. Imagine a detective story. But this story spans galaxies. The clues? Just these fleeting signals. Scientists are the detectives. They're using giant telescopes. They're trying to piece together the puzzle. Every burst offers a new clue. Every observation brings us closer to the truth. The first FRB was discovered in 2007. It was found by accident. Scientists were looking through old data. They stumbled upon a strange signal. It was powerful. It was brief. It came from billions of light years away. Since then, we've detected hundreds more. Each discovery adds to the mystery. These bursts are rare, but they're out there, happening all the time, across the universe. They're like whispers from distant galaxies, telling us something profound. We just need to learn how to listen. Detecting FRBs is a challenge. It's like finding a needle in a haystack. These bursts are unpredictable. We never know when or where they'll appear. They last for such a short time, it's easy to miss them. Scientists use massive radio telescopes to capture radio waves from distant objects. Some are the size of football fields. They need to be big to collect enough energy. When an FRB occurs, it releases a huge amount of energy in a fraction of a second. This energy travels across the universe and reaches Earth. Our telescopes detect it, but the signal is incredibly weak. Scientists use sophisticated software to analyze data and look for patterns. Tiny spikes in energy could indicate an FRB. It's a painstaking process, but it's the only way to find these elusive bursts. The big question remains, what causes FRBs? Scientists are still trying to figure that out. There are many theories, some are more likely than others, but no one knows for sure. It's one of the biggest mysteries in astronomy. One theory points to neutron stars. These are the collapsed cores of massive stars. They're incredibly dense, and they have powerful magnetic fields. These fields could be the source of the bursts. Another theory suggests magnetars. These are neutron stars with even stronger magnetic fields. Some scientists believe FRBs come from black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. As matter falls into a black hole, it heats up. It could emit bursts of energy, including radio waves. Could FRBs be from alien civilizations? It's a possibility, but there's no evidence to support this. Yet it's a tantalizing thought. Are we alone in the universe, or are there other beings out there trying to contact us? Section 4. Celestial Cataclysms, Exploring the Potential Origins. Each theory has its own set of challenges. Neutron stars and magnetars are known to emit radio waves, but can they produce the kind of energy we see in FRBs? Black holes are powerful, but they're also messy eaters. Would their emissions be as short and sharp as FRBs? Some scientists believe FRBs are caused by cataclysmic events like the collision of two neutron stars or the explosion of a supermassive star. These events release enormous amounts of energy that could travel across the universe and be detected as FRBs. The truth is, we don't know. We need more data, more observations to understand these bursts, to unravel their secrets. Each new discovery brings us closer, but it also raises more questions. Section 5. Echoes in the Cosmos, the Significance of FRBs. FRBs may seem like distant events, irrelevant to our daily lives, but they have profound implications for our understanding of the universe and our place in it. These bursts are like cosmic lighthouses, shining across vast distances, giving us clues about the early universe. By studying FRBs, we can learn about the matter that lies between galaxies, the intergalactic medium. This matter is difficult to observe directly, but FRBs pass through it, their signals carrying information about its density and composition. FRBs can also help us understand the expansion of the universe. By measuring how much their signals have been stretched, we can estimate the distance to these bursts and how fast the universe is expanding. This information is crucial for cosmology, the study of the universe's origin and evolution. Section 6. A Universe of Mysteries, the Quest for Answers continues. The study of FRBs is still in its infancy. We've only just begun to scratch the surface, but the future of FRB research is bright. New telescopes are being built, new technologies are being developed. These advancements will allow us to detect even fainter bursts and study them in greater detail. As we continue to explore the universe, we're bound to encounter more mysteries. mysteries that challenge our understanding, mysteries that inspire us to learn more. FRBs are just one example, a reminder that the universe is full of surprises. The quest to understand FRBs is a journey into the unknown, a journey that will undoubtedly lead to new discoveries and a deeper understanding of our place in the cosmos. So, the next time you look up at the night sky, remember those fleeting whispers from distant galaxies. They're out there, waiting to be heard, waiting to reveal their secrets. They're